Okay, so if we look at the Hawkeye quiz, the first question for part A, this is the type of drawing I would have been looking for. Your art probably wouldn't be as fabulous as mine. Of course, labeling these things out, this would be our 45 meters here, that he's on top of that platform. Our delta x, which is what we need to figure out, is this distance somewhere between where he's standing and where the arrow lands. What I'd be looking for in your answer is that all of these Vx's are the same across the board. So that's the same, that's the same. As you remember, the horizontal velocity does not change. There's no acceleration to change it. So that has to stay the same all along. But your VI, or your velocity in the Y direction, this thing is in free fall while it's going in this direction. So this arrow should be growing bigger and bigger and bigger. And it's okay if it goes through the ground. The other thing I did ask for was to show me the resultant or the overall trajectory. I'll see if I can get some straight lines in here, kind of straight lines. While your Vx is larger than your Vy, your resultant would be more influenced by the Vx. But then, as your Vy starts to get larger, it's going to pull it down closer to the Y direction. And so if we follow this, ignore that. But if we follow our resultant vectors, we should see kind of like the flow of the arrow there from our start up here to where it finally lands. So this is what I was looking for answer 1A on the Hawkeye quiz. For part B on the Hawkeye quiz, we were asked what the range is or how far out the arrow lands. This is one of our typical problems where the motion in the Y and the motion in the X are linked together by the time. So we don't have what we need to answer this question directly, so first we have to find the time. We know our initial velocity in the Y, or its initial downward velocity, is 0. Acceleration is negative 9.8 meters per second. Now this magnitude here, this negative, is important here. Our Y direction is negative 45 meters because that's down. And our time, well, that's what we don't know. So to solve this for time, we use our old friend, where are we? Delta Y equals 1/2 AT squared plus VIT, and just plug and chug. We've got 1/2 negative 9.8 times t squared plus 0 times t, which takes care of that. This all equals negative 45, of course. So if we solve for this, we get, actually I'm going to skip a step here, but you need to show me this step. T squared equals 9.18. Take the square root of both sides, and we get t equals 3.03 seconds. So now we have our time. What we need to remember is our initial velocity in the x, or vi sub x, was given as 125 meters per second. And so our time was that 3.03 seconds. So what is delta x? Well, delta x is just our velocity in the x, 125 times 3.03, for a total of 378.75 meters. I'm not being very careful with my significant figures here. So the arrow lands 378.75 meters away from Hawkeye's position when he fired it. So for part C, you were asked, what is the speed of the arrow right before it hits the ground? There's a target lying on the ground. A lot of you got confused by this and thought that this was asking for this Y component here. It wasn't asking for this Y component. It was asking for this resultant vector here. This one is what you were answering, not not the y component, because it wasn't falling straight down. If it had been shot directly up into the air and fell straight down, then yes, that would be the answer that you'd be looking for. So I want this velocity right here, this resultant vector between the 125, because my velocity in the x is always constant. It started at 125, it ends at 125. So I need to figure out what's going on with this piece of velocity right here. So I need my final velocity in the y direction. What do we know? Well, I know that it's been falling for 45 meters. That was my initial height. And I know that gravity is still working on it. So I can use the formula Vf squared equals Vi squared plus 2a delta y. This will give me my final velocity in the y direction. So my v initial in the y was 0 plus 2 times negative 9.8 times negative 45 equals, I get Vf squared of 882, square root both sides, and a final Vf in the y direction of 29.7 meters per second. That is that piece right there. So now I've got two sides of my triangle. I've got this piece right here. I've got this piece right here. If you're thinking Pythagorean theorem, you're correct. A squared plus b squared equals c squared. C squared traditionally is your hypotenuse. That's what I want to find here. So I set this up as c equals the square root of a squared plus b squared. I've got square root of 125 squared plus 29.7 squared. Do your math magic on this stuff, and I get c equaling 128 meters per second. That is the velocity that that arrow comes into the ground with, or that ground target with, 128 meters per second. When you're writing your corrections, I want to see more steps than this. I'm skipping around a bit. I need to see some total underneath your square root sign, not just what I'm writing here.